Okay, I'm going to introduce you to the heat treating equipment that I use. There's basically two things that are going on here. First is a forge, and the other thing is a quench tank. We're going to heat this knife up in this forge. Then we're going to quench it, and that will make the steel hard. Okay, what these things are is that this is a Whisper 3-burner forge. And I like 3 burners because I'm getting a lot of heat really quick. It's also, when I push the steel in and out, I'm getting a very even distribution of the heat rather than if it was just a 1-burner. It's fed by a little, a cylinder of propane, just like in your barbecue grill. And it comes up here and you light it. There's sometimes an explosion. I call it the dragon. And you put the steel in here. That when I do this, I hope I can stand off to the side, so I don't, block the view. And then when it's all up to the right heat, then I'm going to take it and plunge it in the oil. Now, let's talk about that. This was the tank itself was made from an air tank that came off a semi. I think it was for the brakes. And I cut it so it can hold the oil. The oil itself, the quench oil, is Texaco Type A. And I got it when I pitched in with Ed Fowler, the famous knife maker. And we both got some and we split it up. And it's a very good type of oil, Type A Texaco. And you have to heat the oil. Now, a lot of people, different means to heat it. At first, a lot of people just use propane torch and they heat the container and that heats the oil. And a while ago, I was using these. This is an old head from the sledgehammer, and I would heat this up in the forge and just drop it in there. And it was very impressive because there'd be a huge fire, but the oil would get hot, but it would get way too hot. I mean, I'm aiming for 160 degrees, and I was getting up well over 220. And it was always uncontrollable, and there's this element of danger. It made it exciting, but just, I can't do that every time, because you're going to run out of luck. So instead, I rigged it up. There's kind of a heat, here. I think they call it a hot plate. Anyway, it's an electronic burner, just like on an electric range. And that heats the pan, and that heats the oil. Now, to get the temperature right, and that's kind of critical, that you have to be at least 160 degrees. I used to have and make use of this, I think it's an old meat thermometer from an oven, but it's not accurate enough. And I noticed that my wife had this, I think they use it, it's a thermometer, instant thermometer. They use it for coffee. I think she was using it to make espresso. You have to get it a certain hot. And I asked to use it, and I came out here and I put it in the oil, and it gives you an instant reading. And, well, a little later than that, my wife came out and noticed I was using it. She said I can keep it. So, that was nice. It heats the oil, and then you have to kind of stir the oil around to distribute the heat. But we're right at 160. It'll go probably 165 by the time it's done evening out. And that's about right. So we can turn that off. We're actually going to do the heat treatment now. So this is going to be kind of a long video, but here we go. We have to use our safety glasses, and then we're going to start the forge. And it's always dangerous. I won't lie to you. It scares me every single time I do this, especially since I'm indoors, and we could either blow things up or burn the house down. Get that going. Okay. And then we see if this works. Okay. I think okay. Smokes kind of bit, don't it? Okay. Well, that was frightening, but we're going. We're still going. Now it's time to get the knife in there. And I'll try to stand off to the way. I gotta make sure this is recording, or else this is going to be kind of like superfluous. Yeah, we're doing good. Okay. I don't really care if I harden the tang or not, so I'm just going to heat the blade, and I'll start by heating the back of the blade. It's going to take a while here. What you're looking for when we're heating now is when I get to the critical temperature, and that is the temperature where the steel gets hot enough that it becomes non-magnetic. And at that point, I guess the carbon goes into solution or something like that. Whatever it is, I don't know. All I do know for sure is if you quench it correctly at that point, the steel gets very hard. Let that go. So, let me see if they're still recording. Yeah, this is gonna. It's not the most interesting thing that goes on, and that's kind of good because if it gets interesting, if it gets a little too interesting, then your shop slows down. Now, most of the time, I do this in a shop that's pitch black. And that's so you can judge the color, you know, because I'm looking for an even distribution of the heat. But because I'm making this video, I got all my shop lights on. I'm not really standing where I normally stand. I usually stand out, and it's a quick dump, usually here, because I don't want to lose any heat. I think I'm going to be able to heat it up a little bit hotter than normal, just so I can get from here to there, so you can see how it's quenched. There'll be a chance of a flare-up. We're right at 160, it's perfect. And by flare-up, I mean there's going to be a chance of a fire, which is why you wear safety stuff. And I have an extinguisher, which I'm pretty sure still works. Okay. Oh yeah, we're coming right along. Now we can get ready. You can see the tip's a little hot, the blade's got to catch up, and the blade is still magnetic, so we can start working it now. Magnetic. I think the tip, because it's thin, it usually gets the hottest, which is why sometimes I'll heat the spine, the thicker spine first. But I think we're going to be okay this time. These are not normally the tongs that I use. But I just noticed that I never really use these. They're just a pair of long pliers, and they got rubber handle, and the rubber's gonna melt or catch fire here in a second. Almost. Yeah, I don't really have any other tongs. Oh, maybe these will work. Here we go. Are you still recording, kids? Oh yeah. Okay, these are metal. I think the pizza's done. Oh yeah, little spot in the middle, that's not bad. I think I'll heat that up. I'm going for a thorough hardened blade this time. Most of the time I go with a differentially hardened. And that's based on the work of Ed Fowler. Again, he pushes the idea of a differentially hardened where you heat and quench just basically the cutting edge. But this time I'm going with a fully hardened blade. About the only thing that won't be hard will be the tang. It's an experiment. I want to find out, you know, if the knife is better this way. They're non-magnetic. There might be some flare-up now, so be prepared. In the beginning, when I started making knives, I used to scream, "My God, call 911," but you get used to it. Oh, we are ready. So the blade is not magnetic. The spine is, that's where the tang is. The blade is non-magnetic. We're going to get set to quench now. I don't like the tip getting junk on it. There you go. Getting set to dunk. Turn the gas off. Spin around and plunge back and forth. Cool it as fast as possible. That went pretty well. I was scared it was going to catch fire. I don't really have a great grip on it. Right now the carbon's being trapped in the iron, I guess. The molecules. And that's what's going to make it hard. Become steel. Oh yeah. Oh yeah. Now we're going to check and see if it got hard with the file. Okay, I gotta see. Cool. She's still smoking a little. Oh yeah. And you can hear the difference. This, it slides like glass with the file, but the tang, which didn't get hard, you can hear it. Okay. Now while it's still warm, I have to dry the oil off and get it into the tempering oven. That's to make it not fragile. So that'll be the next step.